Hi everyone and welcome to Electrical Know-How. Today we're going to be calculating the total resistance inside of a parallel circuit. So first of all, let's just make sure that we are indeed looking at a parallel circuit. The one that you're looking at should be something like these. So a parallel circuit is a circuit where the current can move through various paths. It doesn't have just the one path to go through. So in this case here on the left, we can see that the current comes in. It can go through path 1 or path 2 and then join back up, come back around and go to the source. So definitely a parallel circuit there. And we've got a very similar thing over here where the current can come along, split into branch 1 or branch 2, join back up and shoot back around. So these are both parallel circuits and basically the current can just travel along multiple paths. Now we do want to make sure that we don't have a circuit that looks like this. And the reason is that we just need to use some different skills and some different techniques to be able to calculate ones that look like these. These ones are actually series parallel circuits or parallel series, the same thing there. So what we're looking at is these components have a parallel component here, here and here, but they also have series components. So we've got one, or effectively one resistor here, one resistor and another, and they're all in a straight line. So that therefore means that we've got a serial with parallel, so series parallel. Same over here, we actually have a parallel which then goes into series. So we've got 1, 2 resistors and these are actually in series. So this one here is a parallel series circuit. So look, there's no big deal, we can calculate these. You just need to do a little bit of extra study and we've got videos on all three of them. So if you want to be able to solve these type of problems, you're going to need to be looking at 3 videos and they're just down below here. So you're going to need to watch this video, which is calculating resistance in a parallel circuit. You're also going to need to be able to calculate resistance in a series circuit, and then check out our video series parallel where we put those skills together and yeah, we can solve problems that are a little bit more complex like the ones you see there. Alright, so let's start off with a couple of facts. So fact number 1, adding another path to a parallel circuit decreases the total resistance of the circuit. So adding another path to a circuit, and you're normally going to put a resistor in that path. When we're looking at the things we're looking at, normally another path has a resistor in it. But adding another path to a parallel circuit decreases the total resistance. It's easier for current to get through. So more paths equals less resistance. Nice and easy. Let's move on to number 2. It gets a little bit harder, but not too much harder. Okay, so the total resistance of any parallel circuit will be less than any individual resistor in that circuit. So in this circuit here, we've got a 50 ohm and a 50 ohm. This is just an example one. So you would sort of think, intuitively that, well, 50 ohm plus 50 ohm equals 100. But you're actually wrong. Because we've got more than one path for that current to flow down, we've actually made it a little bit easier for electricity to get through. So in this particular problem, it ends up being half, which it's actually 25 ohms. So this is following the rule that we're seeing up the top here, is that the total resistance for this circuit is 25 ohms, but the total resistance here of 25 ohms is less than any individual resistor, which we can see there, they're both 50. So just keep that one in mind, and it's a great way to double check your answer and just make sure that, oh yes, I do have that one right. It's a quick little check that you can do. So the third and final fact before we get on with the show is that choosing the right formula depends on the information that you have. There's 2 main formulas that we use, and we didn't go through both of those, but just use the information that you have on hand. One of the formulas is really, really easy. That's the first one that we're going to do. The second one is just a little bit more complex, but it's still really easy as well. So, but just tailor the formula to the information that you've been given. All right, now let's get stuck into it. So, formula number 1. This one's Ohm's law. A lot of us have heard of Ohm's law. It's a really basic concept that people get into very early in their electronics career or in their electronics interest. And what we can see here is that R is equal to resistance, V is equal to volts, and I is equal to amps. So we've got the resistance, voltage, and current here. So all we need to do to find out R is divide our volts by our amps. So it's a really easy way of doing it. It just depends on the information you've got. if you've got these bits of information on hand, this is definitely the quickest and easiest way to do it. So let's take a look at a quick little example of that. So in the circuit, we can see up the top here, we've got 6 volts for this little parallel circuit. We've got 6 volts, 2 amps, and we want to know what the resistance is. It's a question mark. We don't know what it is. So all we need to do, coming back to our previous slide there, or our previous bit of paper, we have 6 volts divided by 2 amps, and it tells us that this circuit here has a total of 3 ohms of resistance. So as you can see, it's really, really easy to calculate it this way. Certainly I'd prefer to calculate it this way, but a lot of the time it's a bit harder than that. So we'll get stuck into formula number 2 now that we know Ohm's law. And this is one that you'll see around in quite a lot of textbooks and things like that. And this is adding individual resistors. Again, we've got examples and we'll go through it in a second. But this here does look a little bit more beefy. It looks a little bit more complex. But basically running through it, we've got 1 over the resistance total is equal to 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor plus 1 over the fourth, fifth, sixth, 7, 8, 9, 10, as many as you've got all the way up. So you can just keep adding those on there. As I said, it looks a little bit confusing, so let's take a look at an example and see what happens. Okay, so example number 1 here. We've got 3 resistors, 1, 2, 3. And inside of these resistors, we've got 10 ohms of resistance here for number 1, 20 ohms of resistance here for number 2, and 30 ohms of resistance here for number 3. So coming back to our previous formula, all we do is we bring those 3 values down into here. So we've got 1 over 10 ohms, which has come from our first resistor, 1 over 20 ohms, which has come from our second resistor up here, and 1 over 30 ohms, which has come from our third resistor here. So we've got 10, 20, and 30. Underneath the line, we've got 10, 20, 30. So nice and easy. Now all we need to do is we divide these ones up. Normally you would just punch this into a calculator, but if you had to do it manually, this is how you would do it. I should say that. So 1 divided by 10 is going to give us 0.1. 1 divided by 20 is going to give us 0.05. And 1 divided by 30 is going to give us 0.03. Okay, so all up, 0.1, 0.05 and 0.03 equal 0.18. So what we've got is 1 divided by 0.18 gives us a total resistance for this circuit of 5.5 ohms. So we can see that there. And again, we use that little check that we talked about earlier, and we know that this resistance here, the total resistance for the circuit, should be less than any of our resistors that we've got up here. So we've got a 10, a 20 and a 30. 5.5 is definitely lower than any of those. So it would seem that we're on the right track. It doesn't mean that you've definitely got it right, but it means you're definitely on the right track there. Let's check out another example of that exact same situation. So in this one here, we're adding individual resistors again. We've got our current coming in. It splits into the top resistor and the bottom resistor before joining back up and shooting back out. So resistor number 1 is worth 200 ohms, and that's for this one up the top here. Right, so we've got 200 ohms. And then for resistor number 2, which is the one down the bottom, we've got 1000 ohms. So again, we take resistor number 1, pop it below the line, so 1 over 200 ohms. And we take resistor number 2, pop it below the line, so 1 over 1000 ohms. And that's going to then calculate out to what we're looking at down below. So 1 over 200 is equal to 0.005. 1 over 1000 is equal to 0.001. And all that we end up with 0.006. So 1 over 0.006 is 166 ohms in total. So what we're looking at for this circuit here is 166. And again, we can do that quick little check. 166 is definitely less than 200, which is our smallest resistor. So it would mean that we're on the right track. And hopefully we've actually gotten that one right. Now, if you are lucky enough to have one of those calculators that'll do all this for you, this is how you'd plug that one in. So you've got resistance total is equal to 1 over 200 plus 1 over 1000. So that's for that previous formula there. But that is how you'd plug it into your calculator, push equals, and it should give you the right answer. So lastly in today's lesson, we're just going to take a look at calculating a missing resistance. So let's say we have we have the total resistance, and we've got a couple of the values of resistors, but we seem to be missing one. So we can use this formula here, which is the same formula, we've just changed it around a little bit. So instead of having the resistance total, which is equal to 1 plus 2 plus 3 plus 4, we've actually got the total minus 1, 2, and then that should give us the missing one. So let's take an example, take a look at an example, and hopefully it'll make it a little bit more clear and a little bit easier for us to understand. So we're going to use the exact same formula that, the exact same example, that we were just looking at. So we know already that R1 is 10 ohms, 20 ohms, and 30 ohms. So, but for this example here, we're saying that we don't know what that first resistor is worth. Now we do know that our total resistance is worth 5.5. We do know that resistor 2 is worth 20 ohms, and resistor 3 is worth 30 ohms. So what we do is we get our total resistance, so 1 over our total resistance, which is 5.5, and then we take off 1 over 20 for this one here that we know, we take off 1 over 30 for the other one that we know, and that should leave us with the one that we don't know. So in this case here, we find that that's 0.18, and that we then want to minus 0.05 and 0.03, and so we end up with 0.01. 1 divided by 0.01, guess what? We ended up with 10 ohms. So again, that's spot on what we were looking for, and we know from the previous example that we had the 10, 20, and 30, so we know that it's right. Again, if you did have a nice calculator that's got the formula functions, then this is how you would punch it in. You just go 1 over the total resistance, 1 over resistor 1 over your first known resistor, and 1 over your second known resistor. That'll give you the total for your unknown resistor. So I hope that we were helpful there, and I hope we helped you out with your problem. That brings us to the end of the slideshow today.